chair tax fiscal year 2017 SR&ED claim. The manufactured chairs, the same chairs that you see typically in banquet hall or in a conference hall, a standard metal chair, as you can see, I'm not sure if you can clearly see, is a metal framing, and the chair has two parts, if you may call. One is a backing and the other one is a seat. Previously, of course, this chair, I pay attention, the back is flat, so as the seat. There is no contour, it's not ergonomically designed. It's just basically a simple chair. To manufacture these seats, initially was made of 5 pieces. I'm not sure if you see it here in the video. This is a board. There is one piece here, another piece on this side. You have, of course, the picture doesn't show it. This is 2 pieces. One piece at the front and one piece on top of it. So we can make 1, 2 pieces, 3 pieces, 4 pieces, and at the end they add another foam, 5 pieces. This foam is 2.5 pounds density. This one's here is 4 pounds density. So they're made of 4 different foams in order to create it. To do this one, as you can see, they develop a fixture system. Call it a device that they could insert the pieces. As you can see here, they put 3 pieces. They apply, robot came, apply glue. They put another piece on top of it. They apply more glue, and the same way the assembly continue. To do this one, this system was working pretty fine, but there were a few limitations with it. First, as you can see, there are numerous pieces, and each piece they have their own tolerances. So combined tolerance could reach as much as 1/4 of an inch. Second, it was not the best way. It was pretty time consuming to put it together, to designing it, to assemble them, because they had to go through various stages and they had to be glued. So the cycle time, the tolerance, the throughput, the quality was not there. To resolve this issue, as you can see, the foam is under it when it is foam aligned or properly put into the device, or a die you may call it. They put a board on top of it, and the robot came and pressed it, and the glue were gonna cure. And this is a finished part. This is the top foam that you can see come around and create a more soft and gentle profile. Despite of this improvement, it didn't work. It was not the best option. To resolve this issue, here we go, this is another good picture. Once the foam were all assembled, they applied the top skin on it in order to create the seat. Here we go. To solve the problem, rather than having 5 different pieces, they thought the best way is to create one piece. As you can see, I'm sure the picture clearly show everything that we see over here is all one piece. To do that one, here we go. This is the nose, the front, as you can see. To create the one piece, they had to completely redesign their approach. In a way, they develop a new die. The die, you can see this is the base of the die. They pour chemical, 2 different chemicals. The first one is polyol, second one isocyanate in a ratio of 2:1. They pour the chemical here, it takes roughly about 5-6 seconds. They close the lid, the door, and they lock it and leave it for 5 minutes to cure. They had a few problems with that when they were developing this technique. when they developed it during the initial prototyping, they could not take the block of foam which was cured to take it out. It jammed, it stuck to the bottom and the surface, so it got excessive damages. To resolve that one, they had to do a series of experiments. They find the best approach is to apply a release agent all around in order to allow it to get out. Next problem that they had so much foam was coming out from all around. Obviously, when the reason for that, the alignment as the door was coming down didn't create a proper tight fit assembly. They had to redesign it, bring the door a little bit further down, tie the tolerance, get a better finish, so when the door was perfectly matched the base when it was in a closing position. Next thing that they did was, I'm not sure if I can show it to you here in the photo. Here, the base I can see is a contour, is coming up, is not flat, is coming up by 2 inches in order to give a geometry profile in order to make it ergonomically more friendly for the user. To do that one, they put an insert. The insert is made of aluminum, raised roughly by about 3/4 of an inch, so allows for the foam and its cure to get that contour. The second part that they had to do here at the back nose, I'm not sure if you can see it here, but the nose they had to do it quite a few times in order to get a proper angle. Is about 180 degrees here, and create a seamless joint. Here we go. Clearly you see 180 degree nose. So when it kind of the chemical cures, develop the profile. Also, another modification that they did to the die was here is basically, rather than taking a cutting it when the finish was when the chair was completed, they went through another process of cutting in order to create an angle to meet their design specification. To eliminate that cutting or shredding process, they installed this flap on the side. There is one here, there is another on the other side. The photo doesn't show, but there are two. So this way they could save themselves additional cutting process. Top view, I'm not sure if you can see. As you can see, there is a nice profile. It is a back seat obviously, but they have ergonomically designed. This is a finished foam. It is raised roughly by 1/2 inch, and the reason for 1/2 inch is raised so the panel can go nicely and sit into it. Here we go, the front nose that you can see, and here the contour you would see is not flat, is a little bit inward, allowing you for better, as you see, is more comfy when the person sits on it.